Hey CW Apes, Mr. Kennedy here to offer you just a very quick video to kind of review the ins and outs of the greenhouse effect. So the greenhouse effect is, as its name implies, well, a way of trapping the sun's energy close to the surface of the earth to keep us warm. The same way the glass windows of a greenhouse trap the sun's energy to keep plants warm throughout the colder months of the year, regardless of where you are. If we didn't have the greenhouse effect here on Earth, our planet would actually be 90 degrees colder than it actually already is, especially at night, where solar radiation radiated off of surfaces that were warm during the day keep us from literally freezing to death. When you think about how the greenhouse effect works in an actual greenhouse, there are glass windows that trap the sun's rays or sun's energy inside the building and keep it warm. Now, it's not enough to, like, say, boil water or something like that, but it'll make a difference when you're talking about like freezing temperatures outside and not freezing on the inside of a greenhouse. Our atmosphere works basically the same way. Without the glass windows, we're relying upon gases in the atmosphere to trap the heat and hold it in. In this picture, you can see solar radiation arriving at the Earth from the sun, some of which bounces off and eventually makes it all the way out into space, but a lot of it is captured by these particles in the air, these gases in the air, and are kept to keep us warm, at least for the short term. Now, when you think about greenhouse gases, the first one that I want to introduce you to is water vapor. Water vapor is the major greenhouse gas, accounting for 85 to 97% of natural warming. Although it is a major greenhouse gas, our activities on this planet don't really seem to affect its concentrations in the atmosphere, so we don't really worry about it, right? We know we need to have it to stay warm, but kind of like no matter what we do, the concentrations stay pretty stable, so we just ignore it. There are, however, some specific chemicals that you learned about in chapter 17 of your book that are anthropogenic gases, or gases that basically people play some role in releasing into the atmosphere. Here they are: carbon dioxide, methane, CFCs, ozone, and nitrous oxide, or nitrogen oxides. Okay? Each of these are listed as pollutants, air pollutants, that are produced by some form of human activity. First, we'll talk about CO2 levels. If we go back to pre-industrial times, when Mr. Kennedy was a kid, CO2 levels were roughly around 280 parts per million in our atmosphere. As time has gone on and industry has kicked up and more people are driving cars and more trees and being cut down and the oceans are being polluted, well, those numbers just keep climbing. As of December 2013, we were at 396.81 parts per million CO2 atmospherically. Now, the sources for this CO2 should be pretty obvious. Industry produces lots of CO2, so does transportation. Go back to that video that I showed you on your air pollution and you'll get an even longer list. The alternative in terms of like a natural source of CO2, if you will, deforestation. So as opposed to industry that's burning coal and oil, if you cut down trees, you're actually adding CO2 to the environment by A, taking away the sink that used to take CO2 out, and B, if you burn that tree, you're putting all that carbon from that tree that had sequestered in it and throwing it up into the atmosphere all at once through the fire, the smoke from burning that tree. It's a double whammy. That's a big no-no. And if you think about polluting the ocean, well, photosynthesis in and of itself is really the driving force behind carbon removal in a natural sense. So plants, algae, organisms like that, they do photosynthesis. They take the CO2 out of the air and they convert it into carbohydrates. That's an awesome way to reduce CO2 levels. But if we're polluting the ocean and killing off, phytoplankton, algae, and we're cutting down trees, we're taking that away. The ocean itself can still absorb CO2, but, in this aspect, it's not really like healthy for the ocean to do it. What I mean is the water and CO2, well, they're kind of attracted to each other. When CO2 comes in contact with water, it forms carbonic acid. So the ocean itself can pull CO2 out of the atmosphere, but unfortunately, that leads to ocean acidification because that CO2 becomes carbonic acid. That can kill coral reefs, that can kill the entire food chain. So, like locking CO2 up in the ocean as opposed to using photosynthesis is really not a good idea. Let's use photosynthesis instead. When you think about emissions by country, you can see that China, the US, are kind of like the #1 offenders here when it comes to putting CO2 in the atmosphere. Industry, transportation, you name it, all of these things play into it. If you're burning fossil fuels in any way, shape, or form, you're putting CO2 in the atmosphere. Methane. Methane accounts for about 18% of anthropogenic global warming. It comes from landfills, cows, natural gas leaks, but cows and landfills, those are the big ones. Each molecule of methane can trap up to 25 times more heat than CO2. That's an insane amount of heat, and it can hang around in the atmosphere for up to 15 years because there's really no like sink that pulls methane out like CO2. Photosynthesis can get rid of it. Well, photosynthesis doesn't like methane, right? So it just hangs out there and keeps trapping more and more and more heat. When you think about how we get this methane from landfills and cows, let me explain how that works. Bacteria are responsible for digesting and breaking down all manner of organic material in a landfill, and oftentimes their waste product is methane. Now, most landfills of today's day and age are being converted to capture this methane and use it in cogeneration plants to generate electricity on site. When it comes to cows, well, that's a different story. You see, cows are ruminant animals and they don't really digest their food very well. They need bacteria to help them. So they'll eat some grass or hay or whatever, alfalfa. They gnaw on it for a while, it goes down into their stomach, and yeah, then the bacteria have to start going to work, and then the cow will kind of like belch that stuff back up and chew it some more. I know it's gross. It's called chewing the cud, and then they'll swallow it down again. Well, all this like chewing and then like chewing it some more and like all that mixing with the bacteria, like that produces a lot of gas. And so 95% of the methane emissions from a cow actually are burps of methane that come up when they do this whole like regurgitation thing. Gross to think about, but that's how their body works. So there you go. Next group of greenhouse gases are the fluorocarbons, probably the most important of which are chlorofluorocarbons, who were once used in refrigerators and as propellants. But there are other fluorocarbons. Basically, when you think about fluorocarbons in general, they account for 13% of anthropogenic warming. And to be a fluorocarbon, you got to have fluorine and carbon together. That's why they're called fluorocarbons, right? So fluorocarbons can absorb 1,500 all the way up to 15,000 times more radiation than a single molecule of CO2. Plus, they really like ozone. The chlorine in chlorofluorocarbons will attack our ozone and destroy our ozone layer. More to come on that in another video. These guys are very stable. They can hang out in the atmosphere for as many as 135 years. So like once you release them, like they're there and they're not going anywhere. Okay. Next is your nitrogen oxides. They contribute 6% of anthropogenic warming, and they can trap as much as 298 times as much heat energy as CO2. Their lifespan in the troposphere is about 120 years. So again, we really don't want to release these into the atmosphere because they, like the fluorocarbons, are kind of like, I don't know, that relative that comes over for the holidays and they just never leave. Like that's what it's all about. So sources for these nitrogen oxides, vehicles, power generation, industry, and agriculture. Check out the pie graph there on the right. Ozone. Well, ozone in and of itself comes in two like locations, but if it's up high in the stratosphere, ozone is okay. But down in the troposphere, like that's where I said in a previous video, ozone is a no. We don't want ozone in the troposphere. There, it contributes to about 7% of anthropogenic warming. Nice thing about it is that its lifespan is only hours or days in the troposphere, so it doesn't hang out nearly as long as your fluorocarbons or your nitrogen oxides. Ozone is a secondary pollutant that can be formed from both your nitrogen oxides or NOx, as well as your volatile organic compounds, and contribute to the warming at that level. All right, ladies and gents. The last thing that I want to share with you is just a summary table of each of these greenhouse gases, their pre-industrial concentrations, their concentrations at about the year 2008, where they come from, right, and all that good stuff. So tattoo this to your brain, learn it well. This is the greenhouse effect. I'm Mr. Kennedy, and I will see you next time.